Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to material science and engineering. So far we have discussed the basic concepts related to elasticity, plasticity, and we have tried to understand the elastic behavior of materials in terms of interatomic forces, potential energy between atoms, and the spring ball model. So in this video we are going to discuss another important concept, which is the application of stress in materials and the related concepts. So the first thing which we'll discuss is what is stress. Now before discussing this, we should understand the Newton's third law. Okay, so basically what it says is that, let us say we have an object, okay, and on this object we have applied a certain force, okay. So there will be an equal and opposite reaction force, okay. There will be an equal and opposite reaction force. So to every action there is an equal and opposite reaction. So stress is basically Newton's third law applied to basic materials. So what it says, that let's say an external force acts on an object or a body. It acts on a certain phase which has a certain area. So in reaction to that external deforming force, there will be an internal reaction force from that material at that point. So the reaction force, the internal reaction force per unit area is called as stress. Okay, the internal reaction force per unit area is called as stress. So most of the time it will be always the stress will be expressed as the external force by area. Why? Because as the equal and opposite reaction force, the external deforming force and the internal reaction force, they are always equal in magnitude. Okay, magnitude wise they are equal. This is the external deforming force, this is the internal reaction force. So that's why always stress is written as the applied force by area, but in reality it is actually the internal reaction force in the opposite direction divided by area. So stress is the reaction force to the externally acting deforming force. Both are equal in magnitude. So that is what stress is. If a body is deformed under the action of an external force, then at each section of the body there will be an internal reaction force that will be set up, and this reaction force tries to restore the body into its original state as per the elastic behavior. So this internal restoring force or reaction force which is acting per unit cross sectional area, that is called as stress. Okay, and as the restoring or the reaction force is equal in magnitude and opposite in direction, so here this magnitude thing, it is equal in magnitude to the external deforming force. That's why if we write it as deforming force by area or reaction force by area, it is the same thing. So an external deforming force acts at a particular point, a particular phase. In this case it is a cube. Particular phase, it has a cross sectional area A. An internal reaction force is set up in response to this external deforming force. This reaction force tries to restore the object to its original shape and size, and by magnitude the external deforming force and the internal reaction force, they are equal in terms of magnitude. And the formula of stress is basically, it is written as applied force by area, and it can also be expressed as the internal reaction force by area. Both are the same because this and this, they are same in magnitude. That's why they are used interchangeably, but their direction is opposite. Okay, the internal reaction force and the external deforming force. The external deforming, the internal reaction, they are the same in terms of magnitude. So this is the formula of stress, force by area. So it is the, mathematically it is the same as pressure. Whereas pressure is the applied force by area, stress is the reaction force by area, but it is sometimes used interchangeably. Okay, the applied force by area is pressure, and the reaction restoring force, which is equal in magnitude and opposite in direction to the applied force by area, that is called as stress. And it has the same units as pressure, that is Newton per meter square in SI and dyne per centimeter square in terms of CGS. Now, this is the basic concept of stress. Now there are different types of stress which acts on body. So these are the different types of stress. First is tensile stress, then compressional stress, then tangential or shearing stress, and then we have bulk or volume stress. So we'll discuss them one by one. So first is the tensile stress. Now suppose we have a force acting on a body. Let's say we have taken a cylinder in this case, or rod, and externally acting forces are acting on the two ends, which are trying it to stretch it or to elongate it, trying to increase its length. So the reaction force which is set up in response to this, okay, the reaction force which is set up in response to this, that is called as the tensile stress. It tries to restore it to its original length, and the externally applied force, it causes elongation, trying to increase its length. That's why it is called as longitudinal stress. Okay, because it causes the externally applied force, the external force pulls on a material trying to increase its length. And the restoring force or the reaction force tries to restore it back to the original shape, okay, the original length, like this. So it is equal in magnitude but opposite in direction to the externally applied force. This is the external force, this is the internal force. Okay, so this is tensile stress. Tensile stress tries to increase the length of the material. So this is the cross-sectional area. So the tensile stress will be force acting per unit area. Okay, so tensile stress tries to increase the length, pulling on a material, causing it to elongate. So this is, it can be, the examples of such is stretching of a rubber band, or when weight is attached to a rope or a string, it tries to elongate it. So these are the examples of tensile stress. Then we have compressional stress. So this is the opposite of tensile stress. Let's say the externally applied force is acting on the two ends of the body, in this case a cylinder or a rod, trying to shorten its length, to compress it. Okay, it is the opposite of tensile. Here length is getting shortened, length is getting decreased. So here the reaction force will be in the opposite direction. Okay, the reaction force will be in the opposite direction, trying to restore the object to its original length. So here the externally applied force is trying to decrease the length of the body. Okay, again this force acting per unit area. Again, the restoring force and the externally applied force, they are the same in terms of magnitude. So the stress is force by area, cross-sectional area. Whether you write externally applied force by area or reaction force by area, it is the same. So this is compressional stress. So it is the reaction force set up per unit area of a body when an external force pushes on a material trying to shorten its length. Okay, trying to decrease its length. So the example of such is, one common example is the compression of a spring, or when a weight is placed on a column, it also tries to compress it, shorten its length. So this is also example of compressional stress. Then we have tangential stress. So in all of these two examples, force is acting normally, perpendicularly on a particular face, on a particular point. So the tangential stress is quite different. Here the forces are acting parallelly on the two faces. Okay, it is parallel to the face. So here this type of force, it causes sliding of one face over the other. Okay, it causes sliding of one force face over the other, which causes bending of the material. Okay, the bending of the material, which can be measured in terms of the angle of bending. Okay, which we'll discuss it in strain. Okay, we'll try to discuss it, this concept of sliding of one face over the other, which causes bending of the body or the material, and it is measured in terms of this angle theta. Okay, so tangential stress is the reaction force which is set up when an external force is applied parallel to the surface of an object, causing it to deform by sliding one part over the other. It is also called as shearing stress. Okay, so examples of such tangential stress is whenever we try to cut an object with scissors, also rivets and welds which are used in structures, pulley rope system, screw and bolt system, they are all example of tangential stress, where force, the external force is applied parallel to the surface, instead normally or perpendicularly. Okay, in case of tensile and compressional, force was acting perpendicularly on the surface. Here it is acting parallelly to the surface. Okay, here in tensile it was causing elongation, increase in length. Here shortening, decrease in length. Here sliding. Okay, sliding of one face over the other, causing bending of the material, which is measured in terms of this angle theta. So that is normal and tangential stress, where normal stress acts perpendicular to a surface, which is tensile and compressional stress. Tangential stress acts parallel to a surface. So here again we can categorize stress into two broad categories, that is normal and tangential stress. Normal stress are tensile and compressional. Tangential stress is the sliding or shearing stress here. Okay, and these are normal stress, which is tensile and compressional. And at last we have the bulk or volume stress. So in this kind of situation, stress is acting uniformly on all the faces, on all sides. Okay, the external force is acting uniformly on all sides, on all faces. So in case of this cube, the external force is the same and is acting in one direction uniformly on all the faces. Okay, so the example of such is a body which is submerged in water, in a fluid, which causes hydrostatic stress or pressure. That is the example of bulk stress. So here the reaction force acts on all these sides, on all the faces, at all points. Okay, reaction force is set up in the opposite direction, like this. Okay, and here like this, in the opposite direction. Okay, so again the objective is to restore the object back to its original length. Okay, so this is the bulk or volume stress. So here we have discussed the basic concepts related to stress. So stress is basically the internal reaction force in response to the external deforming force set up per unit area. Both are equal in magnitude but opposite in direction. So stress is basically the reaction force by area, reaction force acting per unit area, but it is the same as the external applied force in magnitude. So this formula is mostly written in general. Okay, so stress is equal to sigma, which is equal to force by area, force acting per unit area. It has the same unit as pressure, and these are the different types of stress: tensile, causing elongation; compressional, causing shortening; and tangential, causing sliding. And bulk stress is the force acting uniformly on all faces, on all sides of a material, and the reaction force is opposite to the external force acting on all sides. Okay, so this is the concept of stress in materials. Okay.